Hi, welcome to chapter 10.2, Circular Motion Under Gravity. So, in this chapter, we have applied the knowledge of chapter 10.1 and also chapter 9. So now we consider a case, the moon orbit around the Earth. So, what makes the moon to move around the Earth? The answer is the gravitational force. Okay, and the gravitational force become the centripetal force, so the moon can move in a circular path. For the gravitational force, we have gmm over r squared. You can provide the centripetal force, mv squared over r. Okay, so we can find out v, the speed of the moon, that is gm over r square root. Okay. And we can also find the period of the moon in this case by using gmm over r square equal to mr omega square. Okay, and we know we can delete m in both sides. So r cube equal gm equal r cube times 2 pi over t square. So we can find out t square equal to 4 pi square over gm r cube. We can find out the period in terms of radius of between that's the distance between the moon and the earth. Okay, so that is the main point of this chapter 10.2. That is, we have to apply the circular motion and also the gravitation together. Okay, now maybe we take a look on example 6. So you see, and Chinese Space Laboratory revolve around the Earth in a circular orbit. It will be 360 km above the Earth's surface, and we know the mass of the Earth, also the radius of the Earth. Okay, so find the orbital speed v, find the orbital period capital T. Okay, so actually you must have the picture. We have Earth here. Okay, and we have the station here. 360 km above the surface of the Earth, and also we have the radius r here. Sorry, we use RE. Okay, so we can apply gmm over r square equal to mv square over r, because the gravitational provide the centripetal force. So the space laboratory can move in a circular motion. Okay, in this case, you need to know how to substitute R. R here is 360 km plus RE. Okay, so we can get a result by calculation. Second part, find the period. So we have to apply the correct equation. Gmm over r square equal to mr omega square, because we know omega equal to 2 pi over t. You've learned this in last chapter, circular motion. So we can get the value t square equal to 4 pi square over gm r cube. Okay, by this equation. Or you can use after you have find v, so it will be 2 pi r over v to be equal to the time. Okay, time for one revolution, distance over speed. Distance is 2 pi r over v. So we can also get the same answer. Okay, two method here. For example 6. Okay. Imagine there is a satellite revolve around the Earth. Okay. Now the path will be like this. But it will be impossible like this. Do you know why? The answer is the centripetal force come from the gravitational force. The gravitational force should point towards the center of the Earth. Okay, so suppose a satellite here, it move in a circular path. So the net force actually come from the gravitational force, which is pointing towards the center of the Earth. Okay, so there will be impossible to have such orbit like this. Now let's go to example 7. Solar system here. Assume the Earth revolves around the Sun in a circular orbit. In our DSC, we will only think about the circular orbit at a constant speed, and we know the period of the Earth is 1 year. Okay, find the radius out of the Earth's orbit. Okay, now we know V, and then we can find capital T. Okay, you have learned this in chapter 9, circular motion. Distance is the parameter of the orbit, so it's 2 pi r. Okay, over T will be the speed. Estimate the sun's mass. So we can use the equation directly. Gmm over r square equal to mv over r. So we can find out the sun's mass. Okay. Example 8. I will think this is a very important example. You need to derive this equation. That is t squared is directly proportional to r cubed. This is a very important relationship. Okay, you must have a try for this. You need to know how to derive the equation. It will cost about 2 or 3 marks in the DXE exam. Weight of echelon in space. One thing very important, that is weightlessness. What does it mean? Astronauts orbiting the Earth can float around and feel weightless. Okay, now maybe we look at the video.
Watch the state of weightlessness inside the International Space Station.
partnership.
Why can the astronauts and other things inside the space station float around?
Okay. Now this is called weightlessness. Okay. Now you see astronaut feel weightless. Do you know why? Because their weights are not zero actually, but you would like the story a lift in free fall. The passenger fall with the same acceleration as the lift. Okay, free fall with the lift. So everything fall down with acceleration g. So there will be no relative motion between the lift and the passenger, you know. So there will be no normal force acting on the passenger. So the passenger would, I will say, is it will become weightless. The apparent weightless, okay, because they accelerate in the same weight. Okay. For the astronaut, it will be the same. Imagine there's a rocket revolve around the Earth. Okay, Earth, and there's a astronaut here. The gravitational force provides the centripetal force. Okay, so you accelerate towards the center of the Earth. Okay, both the rocket and the astronaut have the same direction, same magnitude of acceleration. Okay, same weight. So there will be very important point here, low and reaction force acting on them by the fall of the spacecraft. So zero reaction force. So we have weightlessness. Okay, because they have the same acceleration, low relative motion between astronaut and spacecraft. So so the astronaut would feel weightlessness. Okay, so you can see from the video. This is the end of chapter 10.2. I would suggest you to try all the MC question in practice 10.2. Okay, and you can check the answer here. For the shortcut, you can find the full solution in the e-class. For the chapter 10.2, 10.1 and 10.2, here the main concept. 10.1, you have learned gravitational force. The gravitational force actually is the weight. Okay, and we can have the equation G equal to Gm over R square. We call this G field strength, which is defined as gravitational force per unit mass. For 10.2, it will be very short, but the knowledge is very important. We would use gravitational force, provide the centripetal force. Okay, so we can find out both period. T square equal to 4 pi square over Gm R cube. Okay, and also we can find out speed, the orbital speed for the circular motion. I would suggest you try all the past paper MC questions. Okay, from 15 to question 19. Okay, you can ask me if you have any problem. For the long question, please try question 42. Okay, now you see there are some calculations here and explanation. Okay, now you can find the answer here. So after you have done the question, take a look on the solution to check whether you can get the correct answer or not. And A part, B part, B1, B2. B3 is OC, okay, of syllabus. And also part C, very funny. And also please try DSC practice paper. This is very important. Okay, there is question 35. Okay, you should you use chapter 10.2 knowledge in solving this question. Here's the answer. Part A, part B, part B2. Okay. Also try self-test. Okay, answer